Here I'm going to go through a Leaving Cert past paper question from 2018 in chemistry. It's an organic question. Question 8. It says, draw the structure shown to show all the bonds in the molecules of B and C. So here you've got B is propane 1-ol. So you've got 3 carbon chain alcohol. And because it's propane 1-ol, the OH group is on the terminal carbon, so the one at the end. It doesn't matter which side you put it on. Okay, so that's propane 1-ol. And C is propanal. So C is essentially what would happen when that molecule gets oxidized using sodium dichromate and sulfuric acid. But you've got 3 carbons, and the last carbon is a carbonyl, so it's got a C double bonded to an oxygen and 1 hydrogen attached to the carbon. The next question then, which one of the 4 compounds contains only 1 tetrahedrally bonded carbon atom in its molecules? So if we go through them, A has 4 because it's butane, they're all tetrahedrally bonded. So tetrahedrally bonded means you've got a carbon with 4 other atoms attached. Okay, those 4 atoms get as far away from each other as possible. They're all bonding pairs around the central atom, no lone pairs, and so it's a tetrahedral arrangement. Propane 1-ol contains 3 tetrahedrally bonded carbon atoms. Propanal contains 2 tetrahedrally bonded atoms. Ethanoic acid, which is D, is this molecule. You've got 2 carbons, one of which is a tetrahedral carbon. So the answer to that question is D. Okay, because there's 2 carbons, only one of them is tetrahedral. Propane 2-ol and B are structural isomers. B is a primary alcohol. Explain the underlying terms. Okay, a structural isomer is a molecule that has the same molecular formula, so the same number and type of atom, and a different structural formula. So that means those atoms are arranged differently. And a primary alcohol is an alcohol where you've got 2 or 3 hydrogens attached to the carbon bearing the OH. So this is the COH, and you can see that there's 2 hydrogens attached to that. So that's a primary alcohol. It's because it's only got 1 carbon attached, okay? And I've gone through those in other videos. So that's a primary alcohol, one which has 2 hydrogens attached to the carbon bearing the OH. C and another compound E are structural isomers. Draw a structure and give the UPAC name for E. Okay, so when you've got propanal, which is there, an isomer of propanal is when you take the double bond and you actually just put it in the middle of the chain of carbon atoms rather than at the end. Okay, so an isomer there of propanal is propanone. So this molecule here and this molecule here have the same number and type of atom, but those atoms are differently arranged, so they're structural isomers. And the UPAC name for E is propanone. It's also known as acetone, but the UPAC name would be propanone. Explain clearly why the boiling point of propanal is much higher than that of butane. So for boiling point questions, we need to consider their intermolecular forces. So here we're comparing C4H10 versus propanal, which is C2H5CHO. So you have to compare the intermolecular forces, and the intermolecular forces here are van der Waals, and here you got permanent dipole-dipole. So The reason it's much stronger is because you've got stronger intermolecular forces there. Permanent dipole-dipole forces are stronger than that of van der Waals forces. The boiling point of ethanoic acid is stronger than that of propan-1-ol. Well, again, we have to compare the intermolecular forces there, and while both have hydrogen bonding, ethanoic acid has more sites for hydrogen bonding. We can have a look at the molecule here. Ethanoic acid actually has one site for hydrogen bonding, but another site for hydrogen bonding, whereas propan-1-ol only has an OH group, so it's only got one site for hydrogen bonding. So ethanoic acid will have a higher boiling point. There's more than one site for hydrogen bonding in the molecule. This will have a higher boiling point because of the fact that it's got more for hydrogen bonding. What is the organic product of the reaction of C with dilute potassium permanganate? Well, C is propanol, so the product of the reaction of C with dilute potassium permanganate is conversion of the aldehyde, or it's just a generic group, to the carboxylic acid. So it's the one where we have 3 carbons, so it's propanoic acid. So it's an oxidation reaction. Write a balanced equation for the reaction that occurs between sodium and B. So propan-1-ol and sodium. So Na plus C3H7OH. So what happens in this reaction is the alcohol actually acts like an acid and gives away its hydrogen. But now we need to balance that. Because we're forming hydrogen gas, we're going to need 2 of those to form 2 of the salt and 2 of those, because we form hydrogen gas, H2 there. So we need to double up on the others to make sure there's the same number of atoms on the left as on the right.